Good morning. Once again, I welcome you to my YouTube channel. I thank you for watching my video and for subscribing, for liking, and for sharing the link. I appreciate so much. This morning, we are going to look at roots of quadratic equations. Previously, we have been seeing how to solve quadratic equations, but now we are dealing here with roots of quadratic equations. So, when we are to consider the quadratic equation x squared plus bx plus c equals to 0 as our general expression which we've been discussing all along, we first decide to make sure that the coefficient of x squared is 1, and that is done by dividing all through by a. In this case, the coefficient of x squared is a, so we want to make it 1, then we divide all through by a. So when we do that, we shall have x squared plus b over ax plus c over a equals to 0. Now, if we make an assumption that the roots to this equation are alpha and beta, we're saying that if the roots to this equation are alpha and beta, that implies that x minus alpha and x minus beta must be the what? Must be the factors. So if the roots are alpha and beta, then x minus alpha and x minus beta must be the what? Must be the factors. And that implies that the equation is given by the product of the two factors. So the equation itself, therefore, will be the same as x minus alpha into x minus beta. So when I expand this, what do I get? I'll get x squared minus x beta minus x alpha plus alpha beta. So from here, I can write this as x squared minus into bracket alpha plus beta x plus alpha beta equals to 0. So from this expression, if I compare this with that, because you're saying this equation is exactly equal to this if the roots are alpha and beta. So that implies that when I compare this with that, then it implies that alpha plus beta equals to negative b over a. It implies that alpha plus beta equals to negative b over a. And alpha beta equals to c over a. And also alpha beta equals to c over a. We don't only stop at making that conclusion, but also from this you can see that if these are the roots, we also make the conclusion from this equation that if the roots are alpha and beta, then that means that the equation can be written as x squared minus, you see here, if the roots are alpha and beta, that means that it is x squared minus sum of the roots, x plus product of the root equals to what? Equals to 0. So we can also make that conclusion. In general, we can also say the equation can be written as x squared minus sum of the root x, then plus product of the root should be equals to what? Should be equals to 0. So if we know the roots to any given quadratic expression, then that means that we can easily get that quadratic expression by getting the sum of the two roots and then getting the product. Then we substitute in the general expression x squared minus sum of x plus product equals to 0. Let's look at e.g. number 1. Here we have the question saying, given that x squared minus 5x plus 10 equals to 0, we are required to find the sum of the roots and the product of the roots, which becomes very simple. So in this case, we say our solution. If the equation is given by 3x squared minus 5x plus 10 equals to 0, this is a quadratic equation. So we should not forget that we have to compare with x squared minus sum of the roots times x, then plus the product of the roots equals what? Equals to 0. So when you look at this equation and this equation, there's a problem. Where is the problem? The general expression has coefficient of x squared to be 1, but here the coefficient of x squared is 3. So you have to first express this in terms of that, in that format. From there, we shall compare. We shall be in position to get the sum and the product. So if this is the case, to make sure that the coefficient of x squared is 1, just like this, we divide all through by 3. So doing that, we shall divide all through by 3, all through by 3, all through by 3, all through by 3. So we shall have x squared minus 5 over 3 x plus 10 over 3 is equals to 0. So we can compare with x squared minus sum times x plus the product equals to what? Equals to 0. So from there, when you do the comparison, you realize that the sum of the roots is 5 over 3, and the product of the roots is 10 over 3. So we say sum equals to 5 over 3, product equals to 10 over 3, which answers question 1, sum of the roots, and question 2, product of the roots. Let's look at the second example. The second example says that we find an equation whose roots are 3 over 4 and negative a half. Find an equation whose roots are 3 over 4 and negative a half. That's very simple. In our solution, those are the roots already. 3 over 4 and negative 1 over 2 are already the roots. So we have 3 over 4 and negative 1 out of 2 as the roots. So we first get the sum of the roots, which is going to be 3 over 4 plus negative 1 over 2. We take the LCM here. LCM here is 4. 4 divided by 4, that is 1. 1 times 3, that gives us 3. Plus 2, 4 divided by 2, that is 2. 2 times negative 1, that is negative 2. So we shall have 3 plus negative 2, that is positive 1 over 4. So this is the sum of the roots. We get the product of the root. The product of the roots will be 3 over 4 times negative 1 out of 2. So we shall have negative 1 times negative 3, negative 1 times positive 3, that is negative 3, divided by 4 times 2, which is what? 8. So we have the sum already as 1 over 4, and we have the product already as negative 3 out of 8. So our equation is given by general expression x squared minus sum of the roots times x plus the product of the roots should be equal to what? 0. So shall have x squared minus sum, which is 1 over 4, then times x plus the product, which is negative 3 out of 8, should be equal to 0. Eventually, we shall have x squared minus x out of 4 minus 3 out of 8 to be equal to 0. So from here, we can make linear equation by multiplying all through by 8, which is the LCM of 4 and 8. So we multiply this one by 8, this one by 8, this one by 8, this one by 8. So when we do that, we shall get 8x squared here, then by 4 1, by 4 2, so negative x times 2, that is negative 2x, by 8 1, by 8 1, shall get minus 3 equals to 0. So this is the equation whose roots are negative 3 over 4 and positive 3 over 4 and negative half. So let's look at this example. The example says that given that one of the roots of the equation ax squared minus 9x plus 9 equals to 0 is twice the other. Find the value of a. One of the roots of the equation ax squared minus 9x plus 9 equals 0 is twice the other, comma, find the value of what? Find the value of a. Still, we do the same way. We say let alpha and beta be the what? Be the roots. So if alpha and beta are the roots, then the equation, of course, we already have it, ax squared minus 9x plus 9 equals to 0. So from here, if we rearrange in terms of x squared minus sum plus the product equals to 0, that means we have to first divide all through by a. So we shall have x squared minus 9 over a x plus 9 out of a to be equals to what? To be equals to 0. So if alpha and beta are the roots, that means that alpha plus beta, which is the sum, is this, which is 9 out of a, and alpha beta, which is the product, it is also 9 out of a. But please don't forget that one of the roots is twice the other. So if they're saying one of the roots is twice the other, and the roots are alpha and beta, that means that alpha is either 2 times beta, or beta is either 2 times what? 2 times alpha. So we have this equation and this equation. We can solve them to get the values of a. So if we say alpha is twice beta, I can label this one to be equation number 1, this one to be equation number 2, and this one to be equation number 3. That is if I've considered this case. Alpha is twice beta. So I'll pick alpha, equation 3, I'll put in equation number 1. So if I say 3 into 1, what do you get? Alpha is twice beta. So that means where there's alpha, I substitute 2 beta. So that means that 2 beta, which is this one, plus beta should be equals to 9 over a. So 2 beta plus beta, that is already 3 beta, should be equals to 9 over a. So by 3, that means that beta the same as 3 out of a. Then that is after substituting 3 into 1. So from there, we again substitute 3 into 2. Let me label this one to be star, equation star. So 3 into 2, when you substitute 3 into 2, what do we get? We say alpha, which is 2 beta, that is 3 into 2. So we say 2 beta, which is alpha, again times beta is supposed to be equals to 9 out of a. So this one is also 2 beta, but this time round is what? Squared. 2 beta but squared should be equals to 9 out of a. Good. So we can label this one to be equation star 2. So if that is star 2, remember we are interested in the value of a. So what we do in this case, beta is already known that is 3 over a. We pick this beta in star 1 and we put in star 2. So if we do that, we say star 1 into star 2. What do we get? We shall have 2 into. Instead of writing beta, we write 3 over a. 3 out of a, but squared. 3 out of a. 2 into beta is 3 out of a, but squared should be equals to 9 out of what? Out of A. When you open the bracket, we shall have 2 into this is 9 over A squared, close should be equals to 9 out of A. This by that, I get 18 out of A squared to be equals to 9 out of A. By 9, 1. By 9, 2. So when I cross multiply this by that, it is A squared should be equals to 2A. When I bring this side, I will have A squared minus 2A to be equals to 0. A into A minus 2 should be equals to what? 0. So that implies that either this equals to 0 or this equals to 0. But please don't forget that A is the coefficient of x squared. So it can never be equals to what? 0. Otherwise it will turn to be something else but not quadratic equation. So we say A is not equals to 0. That implies that A minus 2 is the one which is equals to 0. So A equals to 2 after taking this on this side. And therefore, you make that conclusion that the value of A equals to 2. Thank you for watching. Please endeavor not to miss the next lesson because we shall continue from where you have stopped. Thank you so much. Goodbye. See you.